All right, so this is problem number 16 for the bonus problems for exam 2. This problem is asking us to write the balanced chemical equation for the reaction of acetic acid with barium hydroxide. Then we need to derive the net ionic equation and determine any spectator ions that are within the reaction. So the first thing I want to do is I want to write the chemical equation for this reaction. So we know we're going to have acetic acid. So acetic acid, if we recall, acetic acid is going to have this formula. So it's this guy right here. So we've got an acetic ion, an acetate ion plus a hydrogen ion. And when we put those together, it gives us a acetic acid. And then we've got barium hydroxide. Now, what I should have done here, I'm going to put the charges on these just so then we know why I put a 2 here. So hydroxide has a -1 charge. Barium, if we look at our periodic table, has a +2 charge. So therefore, we have to have 2 hydroxides to create one, to produce successfully with barium. So we know this. And then, of course, if we look at our acetic acid, hydrogen has a +1 charge. The acetate ion has a -1 charge. So we only need one of each for those two to balance out. Okay, so what do we get when we produce these together? Well, notice I have an acid and I have a base. So when we have an acid and a base, water is going to be produced. Okay, and then if we look at these two reactants here, I've got an acetate ion and a barium element. So I can actually create barium acetate with that. So that's going to become, and again, if you look at the charges here, barium has a +2 charge. The acetate ion has a -1, so I'm going to have 2 of those to produce properly with to create barium acetate. So this right here is our reaction formula or equation, but it's not balanced. So the next thing I need to do is balance it. So if I look here, I've got 2 acetate ions and only 1 here, so I can go ahead and just plug a 2 right here. Now, if I look at each individual element, let me see, let's look at bariums first. I've got 1 barium on this side, 1 barium on this side, so those are fine. If I look at carbons, I've got 2 carbons on the left, 2 carbons on the right, those are fine. Let's check out hydrogen. Hydrogen, if I look at the first compound, I've got 3 hydrogens times 2 gives me 6, plus another 2 hydrogens gives me 8. And then in the barium hydroxide, I've got 2 hydrogens. So I've got a total of 10 hydrogens in the reactant side. On the product side, so far I have 2 hydrogens for my H2O, and then I've got 6 hydrogens from the barium acetate. So I need to determine 2 more hydrogens somewhere because I've only got 8 on the right. Well, if I plug in a 2 right here, that's going to give me 4 hydrogens. So I'll give myself 2 waters. 2 hydrogens times 2 is 4, plus 6 from the barium acetate gives me 10. So now my hydrogens are balanced. Let's check out water, or oxygen. Oxygen over here, I have in the acetic acid, I've got 2 oxygens. In the barium hydroxide, I also have 2 oxygens. That gives me a total of 4 on the left. On the right, I have 2 oxygens in my water, plus another 2 oxygens from the acetate ion. So that gives me 4. So this is a completely balanced equation now. So this is the balanced equation for the reaction when we produce products from acetic acid and barium hydroxide. The next thing we want to do is we want to determine the ionic equation for this. So if we look at the individual components here from each reactant and product, we can determine some solubilities, determine solubility charts. Now, one other thing I do want to make sure of is the states here. So if we look at acetic acid, this is actually we determined that this is actually a weak acid. Again, referring to our acid table, acetic acid is very weak, and because of that, it's not going to break apart easily in water. As a matter of fact, it's kind of like sugar in the sense that the compound stays together, but it will dissolve. So we can say that it is aqueous. Barium hydroxide, on the other hand, now this is a very strong base. And again, we refer to the acid and base table. Strong bases will easily break apart. So I can actually just refer to this as aqueous because it will also dissolve in water. H2O, that's just a liquid based on its state. And then if we look at barium hydroxide, or I'm sorry, barium acetate, again, if we refer to the solubility chart here, this is actually a very, very soluble compound. So with that being said, since it's very soluble, we can also say that this is an aqueous component. Otherwise, we've had to put that as a solid. So this right here is going to be our couple states here. So if I do the net ionic equation, let's go ahead and put some things down. Let's see what we can break apart. Again, acetic acid, not going to break apart. So when we put it inside, it's going to look like this. Now there's two of those, so I do need to make sure to have the two. And again, there is a balanced charge out. This is going to, you know, there's the hydrogen and the acetate ion are going to balance itself out, so there's no charge. Now again, with the barium hydroxide, those two will definitely break apart. So barium will have a +2 charge, and then this hydroxide here has a -1 charge, but I have two of those, so I got to make sure to plug in a 2. And then on the right, I've got two H2Os. Again, those are just going to stay the way they are. And like I said, because we said that this is very soluble with the barium acetate, I can break that apart as well. So I've got another barium with a 2+ charge. And then I have a acetate that is a -1 charge, but I've got two of those. So I need to make sure to plug in a 2. So this is the balanced, or this is the net ionic equation here. Or I'm sorry, not net ionic, the ionic equation. So we need to determine what the net ion equation is. So I can look and see if there's any spectator ions. So let me look on the left here. I've got 2 acetic acids. Well, clearly there's not going to be any acetic acids over here, so this is going to have to stay. But if I look at the split apart side, I've got a barium hydroxide. So barium split up and hydroxide split up. If I've got a barium over here, do I have a barium on the right? I sure do. So those are going to cancel. So barium is actually going to be a spectator ion because they don't change. And then if I look at the hydroxides, I don't have any other hydroxides over here, so hydroxide has to stay. And likewise on the right, water's not going to cancel out with anything, so that has to stay. And the acetate ion doesn't react with anything because that has to stay. So what do I get as a final solution here? Well, I've got 2CH3COOH. And again, that was an aqueous state, plus 2 hydroxide ions. That's also aqueous. That's going to come out to produce a hydrogen charge, or water and an acetate ion. Well, actually 2 of those. And that's an aqueous state. So this right here is going to be our net ionic equation with their states. So what was the spectator ion? Well, the only thing that I could cancel out on both sides was the barium. So the barium was a spectator ion because it didn't change. However, everything else was, you know, like the hydrogens, the oxygens, the carbons, those transformed into different products and different reactants based off of the net ionic equation. So this right here is going to be the solution to this problem. And again, barium was the spectator ion. All right, so that's it for this problem.